Hey everybody, this is Games Plus James, and welcome back to our Unity 3D character controller action game, where we're going to continue moving our player around within the world. So last time around, we got our player moving in all the kind of basic ways we want to, and we got him moving using our character controller system instead of just using the rigid body that's built into Unity, because now we can run up these little slopes here, and we don't go flying off up into the sky, and we can run off the side and drop down just like that. So that's all fine and dandy, but what we want to do in this episode is taking a look at fixing the jump that we gave our player. So at the moment, our player is just popping up into the sky and then falling down. And then the next thing we want to do is start making the camera follow the player around within the world. Because at the moment, we can make our player go running off to the side like that. Who knows where they're coming from at any particular time. We want to make the camera follow around. We're going to set up a basic way to do that, and then in the next episode we're going to take a look at creating a more advanced way to make the camera follow the player around a little bit better, but we'll talk about that at the end of this video. So first things first is fixing up our player's jump. And as we said at the end of the last video, it looks a bit weird because we hit the jump button and our player is just flying up into the sky a little bit weirdly. We can also jam on the spacebar and make our player just keep jumping forever and ever. And that's no good for us. We don't want that happen. So we're going to fix that up. So first thing we're going to do is fix up the fact that the player is just jumping around wildly out of control. So let's open up our Playercontroller Script. We have it here. And all we're going to do is take advantage of the fact that the character controller that's built into Unity has a way built into it to check if it's on the ground. So all we have to do is create a new if statement around our jump button, or our jump function here. We'll just say if controller, which is our character controller reference up here, if controller dot is grounded. So basically that'll do a check and see, okay, if the controller is attached to the ground. So then we put some curly brackets, we open that one, we delete the one that's automatically generated if it is generated, and we'll put the final close bracket just after our little jump function here. So basically what this means is it's going to be checking and seeing if we are attached to the ground, and if we are, check and see if the player presses the jump button, and if they do, then we're allowed to jump. Now we could combine these into one single statement. So we could say, for example, we could just copy that for a second, and what I could do is say if the controller is grounded and the player presses the jump button, then we'll do the jump action, and we could just get rid of this if statement here. But I'm going to leave it in here because perhaps in your own game, for example, you might want to take the move direction that we're using. I'm just going to copy that here. I'm going to put this inside here and comment that out. And for example, you might want this would stop the player being able to move within the air. So you might want to limit your player so that once they start jumping, they have to be committed to whatever direction they're going in. It isn't necessarily the best kind of controls for a platformer game. You kind of want to have a bit more control over your movement within the air. But you could also use that to, say, limit how much your player can move in the direction. So say, for example, if the controller is grounded, we could do all this. Otherwise, we could have a slightly slower move speed. That means they can only move a little bit slower within the air. But we're not going to do that for now. We're just going to stick with this kind of basic controls here. So let's save this and test this out back in Unity. We'll let it compile. We're going to hit the play button. And if we jump, we see our player now cannot, no matter how much I jam on the spacebar, we won't go flying up into the air. We just do our little jump, which kind of warps us up into the air and then makes us fall back down. Okay, so that's fine, but what about that whole warping the player up into the air and making it fall back down? That's not really doing us much good. How can we fix that? Well, if we go back into our code, there's a very simple and straightforward way to fix it. So how our code currently working is, we set whatever direction our player is moving, so we get our horizontal axis, our vertical axis to move into the background, and we have it set into 0 because we're not taking any input in on the y-axis. Then we're applying our y-axis input here, and then we're taking away whatever gravity scale is being applied, and then we move the player in that direction. So there's a little bit of a problem here in that, so it goes through that little section here. So say we're not moving along, and then we jump, so we add on our jump force of 150. Then we get to here, and it goes up to the top, goes up to the position that we want it to, and then it starts taking away the gravity. But then on the next loop around, we don't do any movement here, and we do whatever movement we do, it doesn't matter. But on our y-axis, we're setting it back to be 0. So no matter what, our move direction is getting reset back to 0, so it won't kind of contain any momentum going up. So all we want to do basically is change this so that move direction dot y is being given in whenever we pass in our move, or whenever we want to do any move direction. So basically what will happen now is, say when our character jumps, then our move direction will be set to be 150. Then it'll take away gravity from it, so say it'll take away 1, for example. Then it'll become 149, it'll get to the end of this, we'll go back around to the update loop, and then at this point here, our move direction now will be 149. We know we're in the air, so we can't press any more jumping adding onto that, so our move direction won't go up in value, but it'll get to here, and it'll start to gradually decrease. So we'll get to here, we'll get to 148, then in the next loop around will be 147, 146, just using basic numbers for example. So what we end up with then is a very gradual, every frame our move direction is still being applied upwards. So we're still going up every single frame, we're just going up a little bit less and less as we go. And how that looks then in the game, if we go back in here. Oh, I didn't save that. We're going to hit save, go back in here. And if I hit play, now our jump force is going to be way high for what we want to do now, because if we hit play, we'll see our player kind of smoothly goes flying off into the sky, like that. So let's lower down our jump force. Let's say we'll go to 50. Now you can see it's much more smooth. Our player is kind of gradually jumping up into the air and kind of popping up. Let's make it 75. And you'll see as we go, our move direction is kind of gradually being applied to the player, which is perfect. That's exactly what we wanted to do. We walk up here, walk over the edge. We can see we're falling down quite fast. So we can adjust our gravity scale to say 0.1. That's what I kind of do. We're still falling quite fast, but our jump force now, we're able to jump really, really high. So let's pull this down again, like this. Now we see our gravity scale is kind of making us fall down very, very quick still. So we could reduce this down even further. And now when we walk over the edge, we're still snapping kind of to the ground very, very quickly, which is fine. That could be what we wanted to do. But this is why in our previous episode, we started multiplying the... Oh, that's the wrong thing. We started multiplying the direction and gravity here by time dot delta time, because if we multiply this by time dot delta time, it gives us a very small and very fixed value to be subtracting away from here. And even though we're applying that movement to the, or we're applying the move direction to the movement of the player by time dot delta time, decreasing our gravity by time dot delta time also makes sense, because we're not just applying it to the player's movement. So now if we do that and go back in here and we hit play again, oh, we still have our jump force up quite high. Let's put this back down to, actually hold on, we'll restart this. Put this back down to 20, hit play. Now we jump. Of course, our gravity scale now is, we want to actually kind of start adding to our gravity scale a bit higher. So you can see our player now is kind of, it's still falling down quite fast, but it's all about kind of feeling out how this all works in your own character. So you can mess around with the values until you get it. I'm kind of going to leave it like this, because even though it is falling down quite fast, we also now have a lower value for using our jump force on our player. So we can do it like that. We can increase our gravity if we wanted to. You'll see our player won't be able to jump as high, but it ends up with our, we have a smoother kind of jumping arc for our player in general, like this. So perfect. I kind of like how that feels, so I'm going to keep going with this, and we'll keep moving our character around in the world like this. So let's move on to doing the basics of moving our camera around within the world. So to do that, we're going to create a new script over here. Create a C# script that we're going to call camera controller, like this, and we're going to open this up in Unity, or not in Unity, in Visual Studio. Sometimes you need to reload the solution when you create new scripts, but that's fine. I'm just going to go back in here, and before we actually create the script, we're going to apply it to the camera itself. So I'm going to click and drag camera controller script onto there. Now the first thing we're going to do is just make the camera actually look at where the player is within the world. And Unity has a very handy built-in system for doing it. So we're going to create, first of all, a reference to the player. And we're actually going to make this a target reference, which is, we're basically saying, what is the target of what the camera should be looking at? Because maybe later on in the game, we want to make the camera look at something different. We want to make it point at different things within the world. Who knows? So rather than just saying a reference to the player here, we're going to create public game object target, like that. And then all we have to do in our update loop here is say transform dot look at target, like so. So all that does is say, okay, transform of our camera, oh sorry, we need to say target dot transform. Actually, just thinking about it, rather than saying, no, we won't say target dot transform here, what we'll do instead is say, instead of public game object, we'll say public transform. If we go back in here, every single object within Unity has a transform component attached to it, which just gives the position, the rotation, and the scale of whatever object it is attached to. So we know that every object has a transform. Transform is the position of the object within the world, and that's what we want to be looking at, not necessarily just the game object itself, because the game object will obviously have a transform. And then it makes it much more straightforward to just say, okay, transform, look at the target object that we want to do. So the target transform position. So we're saying, so basically what this little bit of code here does is takes whatever our current transform, which is a transform, which is whatever this script is attached to, which will be our camera, and it'll basically make the object rotate around within the world so that it's looking at whatever our target object is. Very straightforward, very simple. We can save it, go back into Unity, and we see now we have a slot here on our camera controller script. And what we'll do is drag our target into here, and our target is going to be our player. So it'll go like that. And now when we hit play, we can see in our game view, if we move our player towards the camera, it moves a little bit, but we can also now move the player around within the world, which is great. That's exactly kind of what we wanted to do. But we could also, our player's kind of going flying off a little bit there. If we get our camera here, and we just zoom out around, there we go. If we drag our camera up in the world, we'll see it'll always stay looking directly at the player, which is absolutely great. We really wanted to be able to do that. We can move it around. If we move around the camera in a circle, no matter what position the camera is within the world, it'll always stay focused on the player. Okay, perfect. That's absolutely what we wanted to do. I'm just going to make some changes here so that we don't have our player jumping around like crazy. So we have our camera's position here. We have it looking at the player. So let's make it follow the player a little bit around in the world. So we'll go back into our script. What we're going to do here is create a new vector tree that we're going to call public vector tree, and we're going to call it offset. And we're going to use this value to store how far away from the player we should be, and then move our camera within the world based on where the player has moved within the world. So how we do that is in our start function. So basically, as soon as the game starts, we want to know, okay, we have set up our camera to be this far away from the player. So let's base how far away we should be from the player based on where the camera is starting. Now, you may not want to do this. You may want to set a particular value within your offset here. But but we'll go with assigning it in the start function here, and then we'll look at how you could set it to just be using given values. So we'll just, in this start function, we're just going to say our offset should be equal to whatever the target's position is. So we'll just say target dot position, because we're referring to transform object here of the target. So normally if you were talking about any general object within the world, you'd have to say target dot transform dot position. But because our target is already a transform object and we're just talking about the transform of it, well, we can go directly to the position. So wherever our target position is, we want to take away wherever our camera currently is, which is our current transform dot position, and that'll give us a value. And then what we can do in our update loop is make the camera move whenever the target moves. So we can just say whatever our camera's current transform dot position, we should set that to be equal to our target's position, target dot position, minus our offset. That's the wrong thing there. So minus our offset. So because we took the target's position and took away our position, when we want to get a new position for us, we get the target's position and take away the offset value. So we'll save this like so, pop back into Unity, let it compile for a second. Now we see we have our 0 values on our offset here. If we press play, we get our offset getting some new values added in. And now if we move the player around within the world, we'll see our camera moves and follows the player around with us. So perfect. So let's move the camera a little bit in relation to the player. So it's kind of a bit far away, and we want to move it up like this. Now, to get a good idea of our kind of basic view, we're going to rotate this forward a little bit. So this is kind of how we're going to see the world based on our camera. So now we'll see if we press play, our offset values are a little bit different than what we had a second ago, but now we're a little bit closer to the player, and we can move around within the world and jump over objects and jump up on things, walk over the edge of different various things within the world, like so. And it just makes our player feel that little bit better. So there you go. That's how we can make our camera follow our player around within the world. But of course, at the moment, all we can do is keep this static camera in this one position. Oh, actually, yes, before I go on, we'll take a quick look at setting these values ourselves. So you saw what that was there. It can be a bit tricky to kind of just know what these numbers should be, but in case you get a feel for what numbers you'd like to use. So let's say I'm going to put this at -5 and minus 10. Now, if we were to press play, those numbers will be discarded because, hey, the player is completely in the wrong, or the script is grabbing the distance from the camera to the player. So let's, I'm going to take just a 10 based on just what the values were there a second ago. We're going to add a couple of, or a new variable in here. We're going to create a public bool that we're going to call use offset values, like this. And so a bool is just a true or false object. It's either on or off. If we save this and just go back in and look in Unity here, you'll see we can check or uncheck the use offset values. So we're going to say if we want to use offset values, we want to use the numbers that are in here. So if we're saying we want to use these numbers, then we don't want to do this. So in here we'll say if we were to say if offset, or if use offset values, like that, then whenever we check the box, it would get the distance between the camera and the player. So that's not what we want to do. That's the opposite of what we wanted to do. So if we wanted to do the opposite of that, what we can do is say if not use offset values. So when you put a little exclamation mark in front of any kind of check or anything like that within the if statement, that means use the false value. So basically we're saying if use offset values is false, then set the offset based on how far the camera is currently from the player. Otherwise, we're going to use the default value. So it won't if that isn't true. So if we haven't checked that box, then it's going to change the values. But we're going to see what happens if we leave it as true. And if we hit play, we'll see our offset values don't get changed, and our camera kind of goes to whatever value we set here. So we can also manually adjust this here at any point within the game. So you can always change your offset values at any point in runtime if you wanted to. But there you go. That's how we can like specify offset values. I personally want to use the camera distance that we have from the player, so I'm going to leave that unchecked like that. But at least we have the option of doing it if we want to. So now if I just hit play here, we have our player being able to walk around within the world, we can follow and everything like that. But what happens when our player is, say, here? It's kind of awkward to see. There's no ground or anything like that. Maybe there's a hole here, I don't know. We could fall down and fall to our death, which obviously wouldn't be very useful to us. So what we really want to do is make it so that we can rotate the camera. And the kind of classic way of doing it here on Unity or anything like that is to just use the mouse to scroll around within the world. It's what you use in any kind of third-person game or any first-person game or anything like that. We want to use that to scroll around, and then we want to use that to be able to control what the direction the player is going in. So at the moment, if we press forward like that, we want to be able to move backward and forward. But if we rotate the camera, we also want the player to start moving in that direction, forward and back. So that's what we're going to take a look at doing in the next episode here in the tutorial series. So for now, thank you for watching, and I will be back soon with more tutorial goodness and more 3D platformer action. Thanks for watching, and I'll see you all very soon. Goodbye.